Welcome back to another part of the video. So just to give you updates on my 12 volt VICTRON Phoenix inverter smart here with my lithium iron phosphate battery, top band, live here in Minnesota, JW Solar USA. Thanks for watching. You guys have seen this project since I started, and for the VICTRONs it's just like a month ago. Well, for the top band batteries, the lithium iron phosphate, I bought from Battery Hookup. Guys, you guys can see how massive or the construction I've done on these batteries. Okay, 4, 8, 12, 16, 20 batteries here in series. So I have 5 strings of 4s. See that? These are the batteries if you are really curious. I got them from Battery Hookup. I'll put the link on the description below, which you can able to use to get your batteries and get some discounts, and that will help you on your purchase. So this is the configuration. So it's 20 batteries each string, or I'm going to make it 20 batteries like a module. I built them just like a module now. So 20 here, 20, 20, 20. I have 80 batteries here. And wired of 5 strings of 4s. Okay, and all parallel. A 4S 5P. 4 in series and 5 in parallel, if you want to use the technical term. So today, I've been setting up these batteries. I don't use any BMS on this build, just because to show that you can able to do other things without the same BMS everybody is talking about, or what is going on right now. I'm using a traditional method. I'm using a different method how to go about this. Not everybody will agree with me, and which I'm not expecting to happen, because everybody agrees with me. That means we are not learning, because we have different ways of doing things in life, which works for other people and doesn't work for other people. Like someone's food is someone or another person's poison. So I can eat certain things and this person can't eat it. Probably is going to almost kill that person because of allergies or medical issues. That's what it is. I built this for my way, or for my purpose, or for my, do I desire doing it? It doesn't mean I can't afford the BMS. As I have a BMS I've never installed. It's a JK, and just for the sake of it. But I want a peace of mind. Some people say this is not a peace of mind. I will sleep, okay, with these guys in my house. I don't have to worry. When I have a BMS, I don't think I would probably want to step out of the house without being monitoring, because BMS can fail. A lot of things are advantages and disadvantages. This one can fail. BMS can fail. Everything fails, because you build things to fail. If you don't build things not to fail, then you're not progressing, because you want to do update, upgrade, and other things. But what I've done here is really complex for me to use even BMSs here. That'll cost me a lot of money, about 80 BMSs, even if I use a cheap ones, because from this point on all the way here is a 12 volt. 12 volt, 12 volt, 12 volt, 12 volt. That's already 5 BMS into this. 5, 10, 15, 20 BMSs if I want to do this. Because all negatives, okay, all the way, and all positives all the way. So I series 4 in series, 5 in parallel. Each string here is 25 amp hours times 5. That's give us 125, 125, 125, 125. So this gives us approximately 500 amp hours at 6.4 kilowatts. Okay, let's done with the battery. I hope you can understand, or maybe get some detail what I'm trying to explain. See right there, LiFePo4 or lithium iron phosphate, 3.2 volt, 25 amp hours. Okay, and I get my 2 hot cables here, and that comes through the VICTRON shunt, smart shunt. Okay, and the loads come to here, distribute to the bus bars. I had videos of these bus bars on my PEEP 6048 MT, the new ones. Check on that, you see the video. Then I have that disconnected termination points right here into a blue seal marine battery isolator or disconnect. It has 2 disconnects. I can able to isolate the inverter right here, and I can able to isolate the charge controller. So right now having a number 2, that's going to be the charge controller. If I want to put in number 1, is for the inverter. So if I put in 1 and 2, I have both devices on. Check this out. See? So it's gonna initialize the capacitor charge. Now I have 1 and 2 here that send message to this one to come on, and the charge controller stays on as well simultaneously with running the power and charging. But if we want to conserve or reserve power, or we just want the charge controller to charge the batteries, maybe in an off-grid situation or tiny home, you are not there, you want this guy to be just tricky to charge the batteries, you can just put it on number 2. So this guy is already disconnect. Or you want the inverter, just put this one and turn the charge controller off. If you are working on the solar, then you can just turn this guy to 1. That's the inverter can still power your loads while you're still working on the array. So it's going to be number 1. So 1 or 2, both of them run. But this one I haven't installed yet. I don't have enough time to put this. This is up for PV. Can take up to about 1000 volts. So I can it even have a security lock here. If you already installed something and you don't want nobody to monkey around with it, then you can put the locks on these guys right here. See, there is a lock. You can able to put a padlock, so nobody can mess with it, turn it on and off, or disconnect, whatever, trying to do some crazy stuff. But if I want to loop one more time on the batteries here, I can able to do this. Some people will say this is not for lithium batteries. For you to have a balanced charge, you need to put it in the bus bars. Yes, it's true, because all my batteries are lithium. They're all without BMS. No BMS built in them, just like these guys here. Okay, this is LG cam. So if I bring you back here, I can able to I build them in a string, because I build them for a reason. So I can able to use one bank of these, or which is one module, and module I can do a 24 volts. I can do a mixed system. 2 of these 24 volts, I can still have another system which is here 12 volt. If I isolate them from here, just a termination point right here, I can take these guys out anyhow I want. That's why I decided to build them this way. I can able to borrow this one and do a 24 volt test by detaching 2 modules. It's got to be a 24 volt. Or I can still leave a 12 volt here running this system. Or I can put them all together and be a grid system. I can use 2 of these for 24 volts instead of a 500 for 4 of these. So it's 250 if I have a 12 volt running here. I want to try another 12 volts with a different parameter, or maybe a different location. I'm going somewhere to do a demonstration for clients or anything, or friend, or to upgrade tiny home, or I want to borrow a friend going on a camping trip, I can do that. I can just take one of these guys. They can drain all the system and give them a little inverter. Or this little guy that I built here, this one has a built-in BMS in them. And I built this one before. Check those videos on my portable generators. And I can do 12, 24, 36, 48. I can do a 48 volt system with this one because each of them is a 12 volt at 125 amp hours. I can do a 48 volt at 125 amp hours. I can do a 24 volt series parallel, which is here. These are, we put these two in series. If I flip this guy, negative is going to be on this guy, then it's going to be a series of 24 volt, then it's two strings I'm going to be having at that time. So 125, 125, they already series, and just put this in parallel to bus bars. Back to the bus bars, I can able to take these guys and get a bus, take these wires and put them, attach them to the buses right here. I can take each string and tie it. It has four studs here, 4 studs in there. So you see how thick is that bus bar? If you can see that? It's almost an inch. It's an inch thick. So I can able to put all these guys there. The reason I have them this way so that they can be a little bit isolated or not too clustered here on the system, because I'm not done yet building the system. And you can see the wires right there, the positive, negative tied into the inverter. So I can do that so they can be properly balanced. Is for other people that has issues about saying they're not going to balance properly, and this is, I can do that. I always build flexible system which you can able to configure in any angle. Whatever you want to do, it will work in any application, in any scenario. You can do that. You don't want to get stuck into one system. I have this guy monitoring everything. I've talked about this bus. I'm talking about these guys. Let's get back here. Since the last time, I already got these batteries finally get into a float mode. I was watching that. So that really triggered me to make a video. I was going to give it to the absorb time. It came to absorb just a very short time, approximately 1 to 2 minutes. Then it jumps right away. Because the floats and the absorb, I just set it into the same. When it gets there, boom, that's it. They have the same parameters. That's how I set mine. And this guy, you see, is the Smart Solar Charge Controller MPPT-15045. Is a Bluetooth capability. I wish I would have set up the other device here, then you guys can see how everything is working. But that will be on the next video. So, speaking about it, I'm not done yet to design this guy. About to use another thing here for safety, since this one has a thing here. You can see the hole right there. You can put a padlock. You can lock it. You can lock it right there, or you can put a zip tie to tie that thing if you want to lock it. You can lock this way and lock that thing there. Then I want to do the same thing here for safety. If I'm taking this thing somewhere, or I left it somewhere, or you want to monitor, or maybe you have kids that maybe not too responsible, or maybe you're scared probably they're going to do something that probably your house is going to be gone by the time you get back, or kids are just really curious, or some grown-ups too, or some individuals that you don't want them to use your power as you store your power. I can put another one, is another blue seal that has a key. I can remove the key. You cannot power this system. These guys are all down. Okay? The battery's going to be sitting there, but these guys are totally down. You cannot utilize any of my power So I'm like a gateway. I'm the one gonna give you the access so that you can able to do something. I can stop this guy from charging by turning this thing. I said, okay, when the charge is out, if I borrow someone or whatever. But I'm not going to let you charge my batteries because I don't know what they're going to be configuring or whatever. And because of that, I'll just say, okay, after the charge is out and you're done. So that's what it is. So now, since it's a, if you see, it's a 12 volt, 230 volts. Is a 2000 VA, which is approximately 1600 watt of solar, of power. Here we get Diamond Series Voltage Converter International, and I picked up this guy. Said this is a 1750, so 1750 watts, and this guy is a 5.5 kilowatts, 5500 watts. International, 222 outlets, 4 110s here, 120s, 110. So I can able to do some tests, and these are automatic, so it doesn't matter. As soon as you plug the input voltage, it knows automatically regulated and tells you like you're feeding 100 or 220 and in, then it's gonna give you the output right here, the meter. This one is built in, the smaller one, the 1750. This one can give you the same thing just like the other one, 120 plug. These are the European, international. This is the American, North America, and this one is built-in stabilizer. In case that some people in the area that the voltage is not stable, so this guy stabilizes the power just like the way, just the word stabilization. He stabilizes things. He does it. Put the voltage. If it drops, he increases. If he increases, it drops it. So you can hear the relays like click, 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 click. It's gonna do that. For those of you already live in the countries that you don't have a stable power, you know exactly what I'm talking about. Okay. You know exactly what I'm talking about. For a lot of people in North America, other places, countries that are really fortunate to have some stability on their power, they don't even understand what I'm talking about. They never experienced that. So this is the plug. So I just cut right there and convert it and use it here. So this is gonna be the plug I designed for the outputs of this 230 volts. I use an outlet like that, and I plugged it into this guy. I took one of these guys off to bring in the 230 volts into this small guy, which is a 1750, which is enough to power this inverter here, which is just 2000 volt amp, which is about 1600, around that. So I'm gonna do a test, a load test, put in this time, because this is the reason why I was waiting, because I had a small transformer. This is the small transformer I had, and I was showing you guys when I was running that Vivo or Vevo, and this is just a 500 watts it can handle. So I want to test small loads in the house here and run the microwave or run the toaster, or I can able to do the tea kettle like I always do my test. But I want to run the house with this system and with these batteries, because I want to try and deplete these batteries a little bit so I can see they can have a proper balance, and try them again and see that, and charge them again and see rejuvenate the batteries, because they've been sitting here. These batteries have been going almost like a year. I haven't tested these batteries. The first time they've been live. So now they're all charged, and I'm gonna use this guy, the 1750, 1.750 kilowatts, and or 5.5, I can use this big boy and try to overmax the system here and see, with the help of the inverter, the help of the transformer, to see if they can do more than that. Okay, they're expensive equipment, but try. This is science and technology, so I want to see. And I tested this inverter transformer. They're very, very efficient. They are not. They have that Toredo transformer, if that's how you call it. It's a big transformer, just like exactly what is here at the VICTRON thing. A big transformer with a hole right in the middle, a low frequency. That's inside here. The transformer inside this guy is almost the transformer here at the VICTRON. Okay, so all the transformer, this is a massive one. It's really heavy from the back, and there's the same transformers, a low frequency, and I tested the drawback, and trust me guys, excuse me, it's almost like 25 watts. And when I tested for 25 watts, it doesn't mean it's coming really from the transformer. It's from this guy here. If I turn this guy on, and I can have the 25 watt to, if it's on, okay, and if I put it into the eco mode, it's nothing. It's not even about 6 watts. 6 to 4 watts. Just keep going in and out, in and out. So these guys don't pull nothing, to be honest with you. So I was so thrilled to see how this thing, everything works out. So I'll catch you back on the next video for the test, which I'm going to be demonstrating here soon. I wish just live stream can be stable. I would have brought you live so that you guys can see how everything goes right here at the JW Solar USA, which you guys can see for yourself. It's not going to be behind the scene or anything. I like to do live streams. I like that, but the thing is, just sometimes the video is so choppy, and you can see just the latency on the thing is really something else. So I don't like to have a video that is all maybe fuzzy and all that stuff. I want the video to be really clear, you know, distinct, whatever. Make it more detailed. That's the word I was gonna use, and you guys can see how clear it is, the clarity. But this is the system, and this is what I'm doing. I'm gonna be running the test, and I'll make the video for you guys to see. Welcome. And the channel right now, what we're facing outside, is all cloudy, but I just have this system tied up into small panels, a few panels on my deck, and see what it is. It's all cloudy. Here are the clouds right there, and see nothing. Welcome to Minnesota. Well, the sun doesn't shine anymore when it comes to fall. I'm just kidding. It's really hard now. It's cold right now, guys. It's approximately in the 30s, you see. And I don't think we're gonna have fall at all. And by the time we know, it's gone. A few days ago, we get heavy snow that just came. I don't know how many inches, but I woke up with a big surprise heading to work, and this is what I saw. Surprise. So guys, this is the weather, and thanks for watching. Like and subscribe. JW Solar USA. Happy Sunday. Bye for now. Like and subscribe. Stay tuned for the test.